Pythagorean Theorem. It is a squared plus b squared equals c squared. Some important parts about this formula, that the a and b, when we're referring to a and b, we are talking about the legs of the triangle. The legs are the two sides that make up the right angle. See how b and a both together form the right angle? These are the legs. It is very important that you use the legs over here on the a squared and the b squared part of things. C is always going to be your hypotenuse. So that's going to fit. So, and it is across from the 90-degree angle. So if you're wondering which one's the hypotenuse, look for the right angle. If it's across from it, that is C. If it's making the right angle, then it's A or B. So we're going to start with an example here. Remember, we talked about this in class. So this is just meant to be a review of the concept to help you out with how to do this. So 5, 9, and x here. So first thing, write the formula. A squared plus b squared equals c squared. And remember that the legs are the ones that make the right angle. So 5 and 9 are going to be my A and B. That will help you to how to set it up. So we're going to go 5 squared plus 9 squared equals x squared, because I've put x in C's spot. So 25, 5 squared is 25, and 9 squared is 81, equals x squared. Now we have x squared equals, I'm putting in a calculator. Feel free to do that. 25 plus 81 is 106. And now, I don't want to know what x squared is. I want to know what x is. So I need to get rid of the square. To do that, we have to square root on this side and square root on this side. And when I square root an x squared, the square root undoes the squaring. So I end up with x. Now we haven't learned how to reduce radicals yet, so we're just going to use the calculator and find the square root of 106. And it is, I like to go to 10.3. And I'm going to do one more example. Notice this one we were looking for the hypotenuse. We're not always looking for the hypotenuse. People make the mistake thinking that we're always looking for the hypotenuse. Not always the case. Sometimes they give you the hypotenuse and you're looking for a leg. So be careful in your setup. So if this side's 6 and I have an x here, so I'm looking for a leg, and then this one will make 10. Now people get confused. Oh no, do I make x a or b? Doesn't matter. Just make it a leg. So I'm going to go a squared plus b squared equals c squared. Write it out generically. It will help you organize your thoughts. 6 squared plus, I don't know b, so I'm going to put x squared there, equals c, which is 10 squared. Now I'm just going to continue cleaning it up from there. So 6 squared, 36, plus x squared equals 100. Subtract the 36, because we want to solve for x. So we want to get x by itself. So I'm moving everything away from x. It was a positive 36. What undoes a positive? Subtracting. So now this equals 0. I don't need to think about it anymore. It doesn't need to be there because x squared plus 0 is just x squared. And here I get 64. And again, I want to know what x is. So I square root to get this back to x. And if I square root the left, I have to square root the right. The square root of 64 is 8. And now we know that x is 8. And those are the two basic parts of the Pythagorean theorem.